Okay, so find a vector representing the velocity of, so we have to find a vector, so direction, we have to find the direction. This is good, I should write it down. Because whenever we're mentioning direction, if you're not given the direction, we know that we have to find the unit vector, because the unit vector gives us the direction where the object or the particle is moving towards. So direction and the magnitude or the speed. Alright. I think I have to fix my tablet again because it's not listening to me. But that says magnitude. Okay, so now we find a vector representing the velocity of the plane when it is descending. So this is positive A vector, and then we have the descend up in the X and Y and XYZ axes, but the A is only on the X and Y axis. So we have a descent here, right? So we have to connect this. So this okay, so this is going to be A minus B, and then we have whatever this, that's actually B, we have B here. So this is vector subtraction, and it's subtraction because we're descending. Okay, so once again we have another way to look at this on the 3D plane would be from the origin. Okay. Oh, I don't know why this. From the origin, we have B going to the point. So this is B, and A would be here. And then this will be A minus B because it's descending, it's going down, okay? If it's going the opposite way, then that means it's not descending, it's actually lifting off and it's taking off to this point. Okay, so let's continue on with C. Okay, so we know that at the A is at 210, so actually we do 210 I plus, oh, I wrote it on the side, so I don't even need that. So 210 plus 10J minus, we want to minus the new point where the plane is at after flying at a constant speed of 250 kilometers per half an hour. It will be that 360 and forward. Okay. Oops, that's totally not the correct way to write this. I plus 60J plus 4K hat. Okay, there you go. So 200, and then we have negative I minus negative 50J, and then we have negative K. Okay, so this is what we have. And let's find the magnitude. So the magnitude will just be, I can write this out, it's fine. Oh, that's not T, it's plus negative 50 squared plus negative 4 squared, and then square root of all of this will give me, I'm going to use my calculator. Okay, so it gave me so this is the magnitude at which it's flying at. I mean, at which it's descending at. So now we have the magnitude. The next thing we want to find out is its direction, right? Okay. So in order to find the direction, we need to have the unit vector. So what would the unit vector be? Well, we know that the unit vector is unit vector, we know it is v over the magnitude of v. So in this case, we already have v, this is v, and we also have the magnitude. So all we have to do, the unit vector, here, I'll just write it like this, unit u hat will be negative over 111.87 I minus 50.87 j minus 411.87 k. Okay, so now we have the unit vector. Okay, let's scroll up a little bit. It says, and then descends. Oh, oopsie. Okay, so to lessen the confusion, it says it then descends at 200 kilometers per hour. So it's saying that from this point to the airport, it's descending at the velocity of 200 kilometers per hour. And what this number that we found earlier, the magnitude of v, so this is was for this velocity vector, and this velocity vector is saying that the velocity vector from at the time where it descends, so at this point in time it descended, and at this point it was at this speed, but we want to find the overall velocity vector at which it's descending at 200 kilometers per hour. So all we have to do is that we multiply the unit vector by 200, and then once we do that, we will have the vector representing the velocity, okay, of the plane when it is descending. So we'll have this right here.